Step 5.3 Model-based methods. First, we're looking at finite mixtures of distributions, and in that also at the special case of finite mixtures of normal distributions. We'll look at the application using artificial data first. We're using function price feature from package FlexClass to generate the artificial data. And we're using 500 observations and a 3-cluster solution. So we load the package to be able to use price features function. We set a random seed for reproducibility, and then we generate our data set PF3, which contains 500 rows, 500 observations, and 2 columns, where one represents price and the other represents feature. For fitting mixtures of normal distributions in R, there are also a number of packages available. One of the most popular and very mature packages is the M-class package we will be using here. And we need to load the package using function with library, calling library on M-class. This gives us some output to see what version we're using, how this should be cited, and this is a contributed package, so you'll need to install it first so you're able to use it. The main function is function mclust with an uppercase M here in the package, and you specify what data you want to cluster, and by default you can specify a range of number of clusters. Here we want to get the solution from 2 to 8 clusters, and mclust will consider also a number of models and will select automatically the best model from all those are fitted based on the BIC criterion. So we fit that function. We see some progress bar here. There is no need to run several random initializations because mclust uses hierarchical clustering first based on a likelihood distance measure to get the initialization. So in that sense, the initialization is fixed, and then also the subsequent EM algorithm, which is used for maximum likelihood estimation, is a deterministic algorithm. So that's the result we get. We see we have the output is an mclust model object, and the best model found among all which were fitted based on the BIC criterion is a 3-component mixture, and this specifies the shape of our variance-covariance matrix. We see we have a spherical shape, so we are fitting spheres, but they have varying volume, which means that there are smaller and larger spheres in our dataset. This is abbreviated as a VII model. This is for varying volume, but they're otherwise identical regarding orientation and shape. We can plot this 3-component model using the function plot. Function plot by default creates several plots we can choose from, but we can already specify which one we are interested in, and then only one specific plot is made. And here we are interested in the uncertainty plot of the 3-cluster solution. Let's put it so that approximately here the x's are the same, so they also have visually the same length. So we'll see we fitted circles. So this length and this length are the diameters are same, so we have circles here, and for circles it wouldn't make sense to rotate them anyway. We have the data points, they have the colors depending on to which component they were assigned using the probability that they come from that component given the values that we observed, and the size is represents the uncertainty. This observation has a certain probability to be from cluster 1, but also from this cluster here. These points have a high uncertainty. And we see the different volume comes from these. I have the same volume. They are equally sized circles, but this one is a cluster which is more compact. And this we can see here with the smaller circle. An additional plot is to look at the BSC to compare all the models we considered. So this compares all the models we considered. And these are the different variance covariance matrices which are considered. So this should be 14. And we see the maximum is here for that model for 3 components. We see there is a large increase between 2 and 3, regardless of which model we are considering, and then it stays pretty stable, but the penalty applied does allow us, so log likelihood wouldn't change much, but the penalty applied allows us to select the 3-component solution as the correct one. Note that MCLUST uses a different definition of the BIC criterion as shown in the book, where we maximize the criterion and not minimize it.